Hello, welcome to video 5b. This video is about absolute maxima and minima. This is Mr. Miller. Let's do it. So here I have pictures of functions that actually don't have any absolute maxima or minimum. So not every function is guaranteed to have one. In this first one, we see that it does have a relative minimum here, and it does have a relative maximum, but it doesn't have any absolute maximum because the function comes down and goes up forever here. So it continues to infinity, and likewise it goes down to negative infinity. So it has no largest value. So no absolute max, no absolute min for this one. On here we have an asymptote. It goes up to plus infinity and on both sides. So there's no point on the graph where it's taller than or higher than any other point. Also, it actually doesn't have an absolute min either, because I think this tail goes down, keeps approaching 0, but actually never reaches 0. So it doesn't have an absolute minimum either. This one has an absolute max at this point right here. So there's an absolute max there, but it doesn't have an absolute min because it doesn't include this endpoint. It comes down and approaches that value, but never actually equals that value. So one absolute max, but no absolute min. This graph has neither an absolute max or min either, because it keeps going up and approaches the value of 10 right here, but it never actually gets there. And same thing down here. It comes down and approaches this y value right here, but it never reaches that minimum either. So because this has open endpoints, it doesn't have an absolute max or min either. This one's kind of crazy. This would be the absolute min, but it never achieves the maximum because it goes up and up and up, but it actually, the actual value at 3 is down here. So this has no absolute maximum either. It approaches 4, but never gets to 4. So the moral of the story is not all functions have absolute maxima or minimum. But there's an important case of functions that do. If a function is continuous on a closed interval, so for instance, these two graphs are continuous functions. You don't have to pick up your pen to draw them. And they include their endpoints. This one at 0 and this one at 7. So if a function is continuous on a closed interval, it's guaranteed to have an absolute maximum and an absolute minimum. On this first graph, the absolute minimum occurs down here. This is a relative minimum, but it's the absolute minimum also. And the absolute maximum occurs at this endpoint here. On this graph, this is the absolute maximum right there, and the absolute minimum occurs at that endpoint. So we're going to see that for this kind of function, the absolute max and min occur either at a critical point or at the endpoint. Okay, in fact, that's what this slide shows. On this first graph, here are the critical points. We have a critical point here where the derivative is 0, a critical point here, a critical point there. So notice that the absolute maximum occurs at these two critical points, and the absolute minimum occurs at this endpoint. Those are the two places it can happen. On this graph, here's the absolute minimum at this relative minimum, or at that critical point, and here's the absolute maximum at an endpoint. Alright, so in general, to find an absolute maximum minimum, what we're going to do is find all the critical points and just try the function at the critical points and the endpoints. And one of those has to be the absolute maximum, one has to be absolute minimum. Okay, so here are the steps on doing it. The first step is to find the critical numbers. So we do that by finding the derivative and setting it equal to 0. So on this example here, we have the derivative would be 4x plus 16, and we want to set it equal to 0 to find the critical points. Well, x equals negative 4 is the point that makes that 0. So we're going to try evaluating f at the critical points and at the endpoints. So we're going back and we're substituting these values into the original function. Okay, so when you do that, at negative 4, you get negative 1. At -5, we get 1. And at -2, we get 7. This is the largest one here, so this must be the absolute max. And this one's the smallest, so this should be the absolute min. Okay? And we have the graph here of the function on the closed interval here. And sure enough, the minimum occurs at -4 right here. And the maximum occurs at this endpoint when x is -2. So that confirms our work here. All right, let's do another example. So first step, find the critical points. And that would be 3x squared minus 6x, that's the derivative. We want to set it equal to 0 because the critical numbers are the values of x that make the derivative 0 or undefined. Here, this derivative is always defined, so it's just the numbers that make it 0. So we can factor out a 3x. We're left with x minus 2. And the numbers that make that 0 would be x equals 0 and x equals 2. You could also use your TI-89 to solve that. All right, so we have our critical values and the endpoints, so we check them. F of 0, f of 2, and f of 3. This function is 1. At 2, it's -3. And at 3, it's equal to 1. So we see that the two endpoints, 0 and 3, are tied for the max. And the absolute minimum is this value, -3. And that matches our graph. These are the two maximums at the endpoint. And the absolute minimum is at that critical point at x equals 2. Okay, here's our next example. We want to start by taking the derivative. So we have 3x squared plus 20x plus 32 equal to 0. This is defined everywhere, so we're not going to get any critical numbers that way. Let's see if we can find where it's 0. So this factors into 3x and x. I believe this is going to be plus 8 plus 4. I think that works. 8x and 12x is 20x. 8 times 4 is 32. We got it. So the critical value for this factor would be -8/3. And the one for this one would be -4. Okay, so we got to find the function at the endpoints. -5, f of -2, and at the critical points, -8/3 and -4. Okay, let's see what I got for those. For -5, I got the value of the function is -4. At -2, the function is -1. At -8/3, it's a lovely -59/27, which is about -2.8. And at -4, it's -1. So the winner for the maximum would be these 2 points at -1, where it reaches -1 actually. So this is a max, and this one's a max. Then for the minimum, the winner is this one. This one's the minimum. Okay, so at -5, we're right here. Yeah, it was that endpoint. That's the absolute minimum. And sure enough, at -4 and -2, those are the absolute maximums. There's a tie there. Okay, we're ready for our last example. What's life without the quotient rule? So remember, the quotient rule is gf prime minus fg prime over g squared. So it would be x squared plus 4 times 4 minus 4x times x squared plus 4, all divided by x squared plus 4. Okay, so this is y prime. So y prime would be 4x squared plus 16 minus 4x squared. Wait, I made a mistake here. Fg prime. This should be 2x. I forgot to take the derivative. So it'd be minus 8. Let's scratch it out. Minus 8x squared all over x squared plus 4. Wow, I hope you were screaming at home because I really messed that up. that should be squared. So g f prime minus f g prime over g squared. Oh, I think I got it. So y prime would be 16 minus 4x squared over x squared plus 4 squared. So the critical points would be where this is undefined. It's actually defined everywhere. The denominator is never 0. Or where it's equal to 0. Remember, a fraction is equal to 0 when its numerator is equal to 0. If you put that in your calculator and set it equal to 0, you will get x equals 2 or negative 2. Well, negative 2 is not in our interval, so we don't have to worry about that one. So it boils down to, we have to worry about f of 2, that's the only critical point in the interval, f of 1, and f of 6. At 2, it is 1. And at x equals 1, the function's 4/5. And at x equals 6, the function is 3/5. So the winner for the max is x equals 2. And the winner for the min, x equals 6. And we see it in the graph. The maximum is right there at x equals 2. And the minimum is that endpoint. We found it without the picture though. Okay, we've made it to the journal assignment. So we just have 2 problems for you, and the basic steps we did are here. So find the derivative, find the critical points or critical values, and test the critical values and the endpoints to see which one is the absolute max and min. Good luck.